Hey everybody, this is Mr. Norton, and today we're talking about reverse engineering. Now, reverse engineering is when you take a product and you break it apart to figure out how it works internally. You could do this for educational purposes, and a lot of people will do this just to figure out how something works. A lot of times you hear stories when people were younger, they would break things just to figure out how something works. It may be the reason why you got into the field of engineering to begin with, which is awesome, because breaking things sometimes to figure out how they work is really a lot of fun. You could do this for educational purposes, just for yourself to figure out how something works, and it's definitely cool to do. But sometimes it's done on a professional level by companies to figure out how a particular product works so that they can make it themselves, whether it be cheaper or maybe have their own spin on it to get into that business and to make a possible profit. You see this in grocery stores with different types of detergents, different types of soaps, different types of cleaning supplies, different types of household items, toys, games. For example, and a lot of people know this, the game Flappy Bird off the iPhone, which lasted relatively short, but then soon to follow came plenty of other games very similar to it. This is the result of reverse engineering, people taking the game Flappy Bird and breaking it down into components to make their own game or spin off of it to get into the business. So it happens a lot in software development. Now, reverse engineering is not just useful in those areas. It has been used and still is used today in counterintelligence. Now, if you think about it, in a war, right, you want to be one step ahead of your enemies. And so we will send out for intelligence. We'll gather intelligence so that we could figure out maybe possible new technology that the enemy has so that we could keep the upper hand. We need to understand these things so that we could counteract. And so reverse engineering is very useful in that as well. So with that being said, you can see that reverse engineering is used in our lives a lot. And it's worth taking a look at, especially for the inspiring engineer. So for the next couple weeks, you're going to embark on a journey of reverse engineering as we go and we figure out how an electric toothbrush works. Now, even though it seems simplistic, you press a button and the bristles move, there are a lot of internal components that could be happening in here that we need to figure out. Whether we would want to reproduce it if we were a company or just to figure out ourselves. And we're just figuring it out ourselves for this case. But there's a lot of internal components that we may not know and to make that toothbrush work. And it may help us to know and understand a little bit more about how certain mechanisms work together to produce an outcome. And this helps as an engineer. Understanding how certain things work, you could apply that knowledge elsewhere into a different project, and just having that experience allows you to be more versatile in these projects to get solutions faster. Helps you to problem solve faster because you know how certain things can work. So we have a basic standard electric toothbrush as I was showing you. And we're, over the course of 2 weeks, breaking this down and looking at various components. The first thing we're going to look at is, how is this toothbrush designed? Why was it designed the way it was? Looks-wise, aesthetics-wise. Aesthetics is just a fancy word for looks. The principles and elements of the design of the toothbrush. So how does it look? Why does it look the way it looks? Why do they choose those colors? The textures with it. Why did they choose the textures on the grip, the certain textures on the grip, the rubber grip? Why did they use certain textures for the bristles? Things like that. We're going to dig deeper into those elements and principles of the toothbrush. We're also going to take a look at the functionality of the toothbrush as we try to guess how this thing works internally and then break it apart to figure out how it actually works. Now, in class, we'll deal with the elements and principles. We'll discuss that. And in class, we'll guess the functionality. But here on the video today, I'm going to show you how to break apart this toothbrush, or how I would go about doing it. With today's modern technology, especially with things that are in motion or could possibly have electronics inside. You have to be very careful about taking things apart. With reverse engineering, it's always desirable to have it work after you rip it apart at all costs. Sometimes that can't happen. Sometimes it will break, and it just, it happens, and you try to figure out possibly how to fix it if you'd want to, or maybe you can get your analysis from the broken part. But if you can have it work and see it work internal with all its internals out, can really help you understand how the product works as a whole. So I'm going to show you how I would take this apart while keeping everything hopefully intact inside. So this is the first time I'm doing this toothbrush, so we'll see how this goes. Hopefully it's a nice easy break, or not break, but it's a nice easy disassembly. Sometimes it happens that way where it's easy, sometimes it doesn't. So let's get into it. So the basic tools that you're going to need for this disassembly are the slotted screwdriver or flathead, and you want a very thin flathead if you can find one. Right here, the one that I have, it's kind of hard to see on camera, but it's very thin and it's nice for prying things open. A lot of times these type of devices have these plastic molds that snap in together that you have to pry open. A lot of your electronics are the same way, and so we're going to have to pry something open indefinitely. I'm also going to have some needle nose pliers with me. I'm hoping not to use this, but we'll see. And I might need a Phillips head if they've hidden some Phillips head screws in there. Again, I haven't taken this apart yet, so we'll see. Before I take something apart, though, I generally take a look to see if there's any instructions on the back or anywhere else that may help me in tearing something apart. In this case, I know that the brush is going to come off because it came with an extra one, and the batteries have to go somewhere. So I would advise you to read through this. I do know a little bit about how this one works, so I'll go right into it. It does come with a cap here, more than likely to keep it clean. I guess if you travel or something like that, you may want to, keep the bristles clean. I'd probably keep it for that reason, for travel purposes. So before we break this guy down, I want to take a look at how it works first. It's always good when you're reverse engineering something to see actually the function of the product. And so let's take a look at how this particular toothbrush works. If I press the button here, you can see that the bristles will shake back and forth. And if you take a look a little closer, there are plastic pieces that are vibrating back and forth, causing the bristles to move. And when I press the switch again, or that button again, it will turn off. Now there's only one mode. It's on or it's off. I guess you could say two modes, on and off, but sometimes toothbrushes that are electronic will have multiple modes, multiple vibrating states, possibly the bristle spin. But in this case, it's only on and off. Now, the reason why this helps me in my disassembly is now I kind of have an understanding of what could be in here. I might not find a circuit board in this toothbrush because there's only an on and off switch. And there's only one mode. There's only the vibrating on and vibrating off. So there's really no need for a circuit board. There's really only need for the vibrating component and the on-off switch. So again, I might not find a circuit board. It just helps me to know what possibly could be in the toothbrush. So without further ado, let's break into it. For the interchanging bristles here, with a little bit of effort, you can pop the top off. Now, with the top off, you can take a look inside, and you see a little plastic cylinder in there. And again, I'm going to turn it on just to see how this works. Now, if I were to stick my screwdriver in there just slightly, you can hear that plastic cylinder is actually vibrating. So that could be the cause or the source of the vibration of the bristles, which is helpful to know. Now, further investigation with the battery, and I think this is a design flaw. It's definitely a design flaw, I think. The fact that the battery holder is difficult to get off. So what I do is, this is where I use a slotted screwdriver and I'll go and pry. You got to be very careful because it's easy to have the slotted screwdriver slip and cut you. So you got to really be careful doing this. I put it into a noticeable gap and I just push up. Go into a noticeable gap, push up, and just work around the entire gap, pushing up slightly until you get the battery holder off. And then you can actually grip it and see it. Now, taking a look inside, you can see that there's two springs, and those springs are connected. And you can see that the batteries are in opposite orientation. This side being negative up and the positive being up. This orientation with this spring setup tells me that these batteries are in series. Now, a little knowledge about batteries: AA's give 1.5 volts. And when they're in that orientation, I believe it was this orientation here, it's known as series because power is running through the battery one direction and into the battery in another direction. Basically, it looks like this. It's as if you plugged in the positive end of the battery to the negative end of the other battery. And that's essentially what the spring is doing. It's allowing these two ends to be connected through a metal contact. And doing that adds the voltage. And so instead of 1.5 volts, you have connected together 3 volts, which is pretty nifty if you have a vibrating component that runs off of 3 volts, which is probably the case in our body. Alright, so what we have here is the toothbrush disassembled halfway, I'd say. We haven't disassembled the body just yet, which is our next task to see how something works. But these are all the components that you're supposed to be able to take off, whether to change a battery or a toothbrush head. And so we have the two bristle heads here. We have the body of the toothbrush. We have the protector for the bristles. We have the bottom case for the batteries, and we have 2 AA batteries here that came with. So we have the components right now of the toothbrush, and we need to break into this casing now to figure out the more internal workings of this guy. So let's take a look. So now that we've taken a look at the functionalities of the toothbrush, at least as much as we can without breaking the body open, we now have to dig into the body. Now the body's not meant to be taken apart, and we have to really be careful on how we do this. We're definitely going to have to use our screwdriver, and let me show you what I mean. You can see that these plastic pieces are molded to fit together, and they're going to be snapped together. As you can see, there's 2 different parts that are snapped together, and there's actually a crease there. It goes all the way to the other side, and you can see the crease following here. So when we take this apart, I'm expecting this light blue portion to separate from the white portion. So what I'm going to do, and it's going to take a little bit of time, it's always better to not rush this part because rushing will lead to breaking something. I guarantee it. I'm speaking from experience. So you're going to grab this slotted screwdriver and you're going to go between a gap, and you're just going to keep wiggling between the crease, freeing up the plastic piece and hopefully unsnapping the plastic pieces that are holding these 2 components together. So again, I'm just fitting the slotted screwdriver in the gap, and I'm gently pushing up. I'm pushing in and up to try to release the light blue portion of the handle from the white portion of the handle. I'm going to work the other side as well in hopes that it will eventually release. So upon further investigation, it's a little bit more difficult than I thought it was going to be to get this handle apart. Unfortunately, it looks like these two halves are connected a lot better than I expected. It's not just a snap on two pieces of plastic together. And it's probably done that way so that it keeps all the, the switch waterproof, which I should have anticipated, but doesn't matter. I figured it out now. So I'm going to actually have to pry this white plastic piece open. I'm going to keep on doing that to see if I can get these two eventually separated. Okay, so I think we're at the point now where I'm going to have to use diagonal cutting pliers. These guys have really made this pretty tight of a seal, so I'm going to have to cut it open, which unfortunately means I'm not getting it back together. So any pictures that you want to take, you should take now. I already tried to cut into it, and I've discovered a part that I completely missed, which was this plastic guy here, which is an O-ring, and this O-ring here is used to keep moisture out from the battery compartment. As you can see, there's a little slot here where the O-ring used to fit, and now that I cut it, it doesn't fit anymore. Well, it fits, but it won't stay on there, so that's where it goes. And so I'm going to take this guy. So it's just things to watch out for like that. Got to be very observant, especially when they make those things clear. There we go. It's starting to come apart now. Feel the wrath of my diagonal cutting plier. Oh, there it is. Man, it took a lot of force. Let's keep at it. I wonder if I get the other side. Maybe if I get the other side, I can break it apart. Oh, let's see if we've actually separated the pieces that we need. Oh, it's almost there. Oh. Whew, this is a workout. So I started going in from the other way here, being very careful not to cut that middle cylinder, because as we saw before, it looked like that had a purpose to the bristle spinning. So let's see if now cutting that top part did anything. There we go. You were no match for my diagonal cutting pliers. No match. Ooh, there it is. And we're in. As you can see, yes, there were some plastic insert contacts here that they snap on together, but it's such a tight fit that you'd have to pry it open. Probably don't need to go in with an X-Acto blade, which is nice. We'll just go in with diagonal cutting pliers here and here, being very careful of the cylinder in the middle. So cutting here and here with the diagonal cutting pliers, here and here as well with the same diagonal cutting pliers, will allow us to pry it open. And doing so, we'll be able to get these two separated. Now the top piece here, the button, if we take a look, is really just a foam pad. And so this is the part that I'm pressing, but it's really not the true button. The button is actually in here. So this is the guy that I'm looking for. And if we take a look internally here, it's actually really neat. See if we can get focused on it. There it is. See that blue piece here? That's the button. And that clicking is making it click on and off. So this is why it helps to keep the body somewhat intact if you can, because hopefully I'll be able to test this guy with half the body open. So, put the battery housing backwards. There we go. Okay, so now we have the battery pack on and the battery's back in, and you can see that I'm touching nothing electronic, which is nice. The button's still plastic, so I can test this safely without getting shocked, which is nice. Not all applications of reverse engineering will you be able to do this. Only in safe instances should you ever have a circuit exposed and running power to it. Only if it's a safe case. In this case, I'm not touching any exposed wires, or have the threat of touching exposed wires here, so I'm going to be able to run it. And you can see that pressing this blue button here, you can hear the clicks. Pressing that blue button will turn the machine on and off. So let's dig even deeper into this guy and see what we got. So we're going to take this guy off. And as you can see now, we're getting into some Phillips head screws here. You take a look. We have Phillips head. Yes. So I'm going to have to switch to my Phillips head bit. Take these guys out here. Now for parts. With reverse engineering, it is very, very easy to take parts out and lose parts. And so a good hint or a good technique is to have compartments for your parts that you're taking off. And so I have one of these guys here that I'm going to use. But you can use, paper bowls, paper plates, perhaps. Anything that you have lying around the house that could be as a small compartment, you can use. And it's just to keep all the pieces together. That way they're not getting lost, because you can see very easily how messy things like this can get. Now, bigger components I can leave out, and they don't have to be there, but typically my, any screws or things like the O-ring belong in the compartment. So now I have the two screws out. Let's see what that frees up. So those two screws were holding this assembly into place here, and I can pull this assembly out. And lo and behold, remember that rod that we poked the screwdriver at and I was saying it was vibrating, right? Well, that's the same rod that's vibrating here. So it's actually really neat. I was not expecting this. I was guessing with some 3-volt application, possibly a DC motor, but it's really neat in how it works. I gotta turn this on and see what we get, how it's vibrating. Let's see if we can connect this guy here. So if we have a variable power source, this setup becomes a lot easier. We'll be able to, in class, run some alligator clips to the negative and positive leads and run 3 volts into the motor. However, at home I don't have that, so I'm going to have to lean it up against the battery holder and the batteries. Doing so, I'm making sure that I'm only holding the plastic components of the part, not to touch any open circuitry. Okay, but here you'll see that I'm actually able to run the motor still. And you can see that this is nothing more than a DC motor. So there's the cylinder, and you can see, if I can move that, you can see the cylinder actually spinning on the top, and that's spinning the white piece here. So this is a 3-volt DC motor that we have powering this toothbrush, which is very interesting. On the inside, you can see that we have a simple circuit wiring this DC motor here. get it in camera. We have the yellow wire wired to negative and the red wired to hot or positive. And that's going into the DC motor here, which is attached to this spring. And I suppose the spring is there just to be as like a suspension system or a shock system to the motor, so that if it presses in, you can see you can press the motor in and it won't bugger up the wires. So that's nice. So this blue button here, if we take a closer look down here, we see the internals of the switch. Now the switch is known to be as a normally open switch, which means that the circuit's normally open when the button's not pressed. In this case, the button's not pressed, and therefore the circuit would be open or not work. When you call a circuit open, it means that the wires or the connection going to the motor is not connected. There is something open in the circuit, like a door is open. And it will not work until you close that door connecting the circuit. I'll show a diagram showing exactly what that means, and it'll make a little bit more sense visually rather than by words. But an open circuit, or a normally open circuit here, means that, or excuse me, a normally open switch means that when the button's not pressed, the circuit won't work, and when I press it, it does work. So normally open switch means that your circuit is not working when the button is not pressed in, and when you press the button in, the circuit works. It seems trivial, but there's actually something called a normally closed switch where the opposite occurs. When the button's not pressed, the circuit is working, and when the button is pressed, the circuit stops. And that's pretty common in emergency switches. Now this switch is pretty interesting because it actually has 6 inputs, so it's going to take a little bit more research to figure out more into that. I don't know that off the top of my head, but the way this is wired, you can see that this particular switch here, the hot is wired to one of the legs here, the negative is soldered into the other leg here, and that's working the switch. So if you figure that out, what type of switch that is with the 6 prongs, that's awesome. Figure it out, let me know, and we'll grow in knowledge together. I'm going to try to carefully pry the white piece off the motor, although, oh no, it did work. Okay, so let's take a look. So taking a look here, this DC motor, this is typically what a DC motor looks like without anything into it. And we could desolder this DC motor and actually use it for something else. But this is a DC motor, what it looks like without anything to it. You got the motor shaft there and the DC motor. With the model number, if I was to pull this all out, you would see the model number of the DC motor, and you could actually pull motor specs for it. Here's this black spacer, rubber spacer here, for the motor and the plastic piece. That's just to cover pieces of the motor shaft so that it doesn't get bound up with anything that could fall into the toothbrush. That's my speculation of that. And then we have this vibrating piece here, which doesn't really look like too much. It looks like just a typical plastic cylinder. And the plastic cylinder, my camera's having a hard time focusing, but this plastic cylinder, the hole is cut out in a way that it snugly fits into the DC motor. So the hole's drilled, the hole drilled in this plastic for this plastic piece is very similar, maybe just a hair bigger than the motor shaft. Or it was drilled the same as the motor shaft and then pressed in order to have it snugly fit. So it's very hard to pull out this plastic piece, which is what you want. You don't want it falling off. So now if I take this plastic piece here and I plug it into the bristle head here, you can see that they fit snugly, and that's what's connected internally. The inside piece here, which is very loose, is connected to the bristles here. And when this piece vibrates or shakes due to the rotation, this piece is inherently shaking the bristles. And therefore you have a vibrating toothbrush. So that is the internal components, at least on the body side, of this vibrating toothbrush or power toothbrush. But we have one more component to dig into, and this we're not going to get back. We're going to have to destroy a little bit, and that's the bristle head. So let's get into that. Now, in breaking this piece apart, safety is always first and paramount. So as I'm using these diagonal cutting pliers, I'm going to make sure that my fingers are not in the way and try to cut as slowly and smoothly as possible. There is no easy way to do this. There are no ridges that I can try to pry open. It is a solid plastic piece in which this loose plastic piece is surrounded by, so I'm going to have to cut into it. Now I'm going to try to cut the outer shell of the plastic piece without cutting the internal plastic piece. This can be kind of difficult since there's not a lot of room. So I'm going to cut a little notch out here just to get started and work my way down. I'm just going to keep cutting in. There we go. Cut open and pry, cut open and pry, cut open and pry. Interesting. So my initial thought process of the DC motor shaking the plastic piece here was wrong. And it happens sometimes. You think you understand something fully 100%, but then you're able to dig a little deeper and you find something else different. So check this out, guys. If I turn the shaft here, you can see the bristles actually vibrating. So that plastic piece was probably cut on center, and the vibration of that plastic piece had nothing to do with the bristles vibrating, which is neat. And I'm not going to edit that part out where I said the other thing, you know, where I thought the DC motor was vibrating, because I feel that's important. You know, sometimes you come to conclusions that may not be correct, and upon further investigation you find out that those conclusions were incorrect, and you have to reconclude or fix your original statement. So that's what's happening. As this spins, these turn. So now I'm even more interested in what's on the inside here. So let's get to that guy. So I'm going to try a new tactic here because it was getting a little tough to break into the head of the toothbrush. Very carefully am I cutting a little slit into the head near the bristles. I'm going to try to peel the plastic housing off around these rotating, or excuse me, the vibrating bristles. Let's see what we got. I guess it's nice, not technically with this mechanism here, because you know you've got double of it, so if you screw up once, I guess you can do it again, but technically you don't want to have to redo it. Oh, there we go, we're in something. Okay, so the housing definitely has something to do with it. So I broke this housing around. I broke it off. And so I broke the housing around the bristles off. I used diagonal cutting pliers to go carefully in, not breaking this internal component, and I peeled it off using needle nose pliers. And if you take a look inside, there's actually ridges. Again, the camera is going to be hard to focus, but you'll see it with your toothbrush. There's ridges inside here that are holding this component up, and there's a little indentation for the motor shaft to go into. And when this is pressed upwards, see if I can get it back up there. Okay, if it's pressed in, it will keep the bristle piece in place as you rotate and shake it. Okay. What's happening is this hole that they have here, it's actually a slot. It's very interesting, this bristle piece. Let me take this out. This bristle piece here is it's slotted so that when you rotate the shaft here, it's actually sending it left and right. it's shaking the bristle rather than just spinning it, because it's sliding around that slot. So that's actually what's causing your vibrating motion of the bristles, which is pretty neat. So let's put that back in here and let's see if we can reproduce it one more time. There we go. Put that back in there, and yeah, we got it. So didn't expect that one, but that's pretty neat. So further investigation of this metallic rod and these bristles show this. Within the bristle there is a slotted opening here, and that fits within the metallic rod. And the metallic rod is actually bent up. You can kind of see it here. You see it's not completely straight across, it's not flat, it's got little ridges in here. It may be easier to see with your toothbrush, but it's got little ridges, and if I hold this in place, which the housing does that we ripped apart from it, or we ripped around, you can see the actual bristle moving back and forth. And that's the secret behind the vibrating bristle, which is pretty neat. So class, that's reverse engineering, and that is the electronic toothbrush from the inside out. Again, you got to be careful when you break things apart, because you got to make sure not to tear apart the internal components. What could have happened is we could have sliced one of these wires open and then it would not have worked. Thankfully that this is a simple circuit, so we could fix that. But in more complicated circuitry, you really don't want to have to get into fixing anything to investigate. You want to just have it work as much as possible. And in this case, we still have a working component. Whether it does what it was supposed to do or not is a different story. As you can see here, I've invented the next ear cleaner or 360 brush. Hopefully it doesn't fall off. I've already done this before. So thanks for watching. I appreciate. Oh, there it goes. Thanks for watching. Have fun tearing this thing apart. Make sure you document everything. Take pictures along the way. It always helps. And take measurements along the way. Don't lose the parts. Use the component bins that I recommended. And again, just have fun learning about how this electronic toothbrush works. I'll see you guys later.